Okay, all right. Let's walk through it. Now, one of the questions I got on the online, because you went to the website, you watched videos, and this is from a different class. They said, Ward, when you do the picture-in-picture on the slide here, it's covering up the work you're doing. Yeah, I understand. But if you just looked at, because you obviously were on my website watching the video, if you just looked above the video, I have the slideshow of what we did in class. Those don't have my picture over top of it, so you can see the work I wrote down. What? So people were getting thrown out by the video, and I put the picture-in-picture of this camera on the video so you can see my face, my reactions, and how we're doing problems from this, because it's like in the corner. And they're complaining that they couldn't see the work in the corner because the picture-in-picture of my face was over top of it. You just look at the pictures above it, and it has the slideshow of all the work we did, and there's no...
I'll have to look tomorrow.
So, what?
You tell them to show up to class or show it up to your Zoom, but you don't have to worry about it.
It's true. I didn't want to say that. I can't say that. All right. Anyway. What?
Are they on right now?
Yes. Okay. Let's walk back, or let's walk through a few problems. I got 4 problems I'd like to go through.
Okay, this lies because it says Illinois has more cases than we do.
Kim's like doing research. Yeah, probably Kim's doing a bunch of research. All right, or she didn't look at it at all. All right. Anyway.
So you lied because look how far out.
You didn't lie. Kimmy lied.
That's Kimmy. So Kim COVID.
It might not be updated
so
there, she just said something like what, 2 hours ago?
Yeah. So
maybe we dropped like 15 seconds.
So
that's okay.
Alaska's doing really well. They have 2,000.
Well, they only have what?
they socially distance themselves by like hundreds of miles, so it doesn't matter. There's only, I think the average person per square foot is like you have like 100 square miles per person.
Yeah.
So yeah, it's pretty wild. It's pretty big. All right. Yeah. All right. Anyway, let's do some derivatives. So what we have to do again. If you can't get your textbook, call the office. They'll put it in the drop box outside, Isaac. So that's to answer your question there. You can talk to the office. They'll put it in a little drop box outside. You can pick it up. Okay. All right. Yeah, or you can have one of your friends drop it off to you. All right. So now let's talk about the power rule. So let's do a quick example here. I'm going to just write up here just so you guys can see this. Okay. All right. For the power rule. Shh. Third example, or we're going to do 3 of these. The third one is the one you have to put on the Google form. So let's talk about the basic power rule. 7x to the 4th plus 9x to the 3rd minus 24x plus 7. Okay, so yeah, so what you do is you start multiplying the numbers. So you drop the power out front, and then you multiply by it. So when I drop that 4 out front, it's 4 times 7. You multiply it. Then you're going to subtract 1 off of the variable. 1 power off. That's the power rule. What? Yeah. I know. She has all these numbers. She showed a thing on the chart, and we were like, the only county that was above us was Wayne. Wayne County was like 33%. So. Yeah, the number she showed, and I have a picture of it. We were like top, so.
Because this is not making
what you're telling me. So.
She just wants us to make us feel good.
Yeah. So I have a picture of what she showed. So.
We're doing amazing right now.
All right. Okay. Anyway, so this makes 28x to the 3rd. Then I'm going to drop down the next one. So I'm dropping this next down. I'm taking 3 times 9x squared. So that's 27x squared. Then for the 1, I'm dropping the 1 out front. So it's 24 times 1. And then that's a negative 24 times 1, which is negative 24. And then the x would actually drop off because this will be x to the 0 because you have to subtract 1 off the power. Now, if there's any constants, these are gone. Shh. Any constants, the numbers disappear, and this is the polynomial that we should be getting down to. That's the power rule.
I'm really confused what's going on.
They're sitting outside. They want to be a part of class, but they're not supposed to be here. So
that's what I gathered.
Is that legal?
No,
Why?
I don't know. They think it's funny. So
that's what they do.
Is it Brayden and...
So,
well, Mr.
right.
Williams just pulled in the driveway, so.
Let's hope he goes talks to him. All right. Anyway, at least they're on the Zoom. I can't fault them for that. All right. Let's go to the next problem. Question number 2. All right. Question number 2. Let's walk through it. So. Okay. So this is second problem. Second problem. This is not the one that you're putting on Google.
Third, second derivative.
So, all right. So now let's talk about second derivatives now. So this is the second problem. We're going to do the second derivative now. Now remember, second derivative, what it stands for acceleration. The first derivative is instantaneous rate of change. That is your velocity. Second derivative is acceleration of an object. It's how fast you're changing your speed, as opposed to just how fast you're going. There's a difference. The original function is a positional function. It's where you're at in terms of distance. The second one is velocity. That's the first derivative. And then the second derivative is acceleration. So second derivative, we're going to do the same problem that I just did a little bit ago. That's 7x to the fourth, 9x to the third, 7x to the fourth, 9x to the third minus 24x plus 7. So let me just double check.
Why don't you just put 28?
All right. So yeah, just like you were saying, I agree. And that's why I'm going to keep flipping back and forth. So when you do the second derivative, when you took the first derivative, what we already had was the 28x to the third, the 27x squared, and the minus 24, right? That's what we just had a little bit ago. That was the original problem. When you do the second derivative, you just do it again. And so how this is marked, if the original function is f of x, right, that was the original function, the idea is that this one is f prime of x. So it's the first derivative. And then the second derivative is f double prime. That's how they mark second derivative. But it's the derivative of the derivative. So it's dropping this 3 out front, taking 3 times 28. So 3 times 28, we're going to get 84. And then 2 times the 27, that's 54. Oh, and I forgot to put the x to the second. Shoot. X to the second, because you have to subtract off. And then we drop down that power, that's 54x, because you have to subtract 1 off the power. And if there's any constants in the back, those are gone, so this is my answer. Questions with the second derivative?
No.
Okay. So, that's kind of our goal. This is what we want to look at, right? First derivatives, second derivatives, do we know the difference? Do we know how to find them? That was the big thing from the other day. Was there a question in the back I heard?
No.
Yeah.
Yes.
Are you ever gonna have to do a third one?
No, not for me. I don't use that. Algebra or Calc 1 in college, I had to do a couple. There's just like a problem on a test that said find the fourth derivative. You just do it again and again and again. I'm not going to make you do that. The only thing we need is the second derivative. We need acceleration. So that's what I use it
We
for.
like to go fast.
So, all right. Let's move on to the next. So this is the third problem. This is the one we have to put on the Google form. So this is the one that I want to make sure of that you know how to do. So let's talk about the third example. So this is, I'm going to put a little asterisk next to it. This is the one you have to turn on Google and answer the question. I'll give you a little bit of time when we're done here. All right, so whatever the problem is, it could be any item that we have. So this is negative 5x to the negative third plus 10x squared minus 20x to the negative 1 plus 10. Right? It could be a crazy polynomial with weird powers and other things in it. You just drop them out front and you subtract 1 off the power. So now I threw negative powers up here. Those are on purpose so you can see what would happen because we haven't really talked about this yet. This is something we're going to look at in the next example. Let's kind of walk through this one here. So we're going to drop the power out front. So we're gonna I'll switch up the color here. We're going to drop this negative 3 out front and take negative 5 times negative 3, and then we're going to subtract 1 off the power. So when I do this, what it turns out to be a 15, positive 15, and then this is x to the negative fourth. You have to subtract 1 off of a negative 3, so it becomes more negative, like a bigger negative number, or a smaller negative number.
So you add.
So yeah, you're technically adding because it's a minus 3 minus 1 more, right? And then on the next one, we drop the power up front, so this is 2 times 10, and we subtract 1 off of it, right? So this turns out to be 20 x to the first. Then the next one, I drop the power up front, so this would be negative 20 times a negative 1, and then we subtract 1 off the power, so negative 1 minus 1 more. So this turns out to be positive 20 x to the negative 2.
And 0.
And then 0. Because the 10 in the back is always constants, always turn out to be zeros because the variable had a 0 on it. So,
You want us to include 0 in our answer?
No, you wouldn't have to. Nope. So especially on the worksheet that we have due tomorrow night, that where you define the first derivative of those problems, you do not have to put 0, so you can just drop it off. I just modified that thing yesterday, what we talked about in class, on that worksheet that's due tomorrow by midnight. You have to submit it on Google Classroom, even the ones that are in here. Only one question you have to do by the differential quotient. You have to prove what your answer was by doing the power rule. But this is the thing you have to enter. So if I was entering this in Google, and you can do that right now, this is what I want you to enter. That's what I want.
That's the second derivative.
So.
You said
Yeah,
Oh, second. Oh, I'm a dork. I'm a dork. Hold on, I'm a dork.
I'm right.
Okay, hold on. Okay, we got to keep going.
I win an extra one.
Oh,
Yeah.
it's still negative though?
So,
Ah, dude.
What?
No,
All right.
I ain't right.
okay. Yeah, you're right. I totally forgot. We got to do the second derivative. You're right. Second derivative. That was the whole point why I did the last example. All right, so second derivative. We have to drop the power up front. So negative 4 times a 15 is negative 60. And then we have to subtract one more off it, so it's negative 5. So it's negative 4 minus one more. And then we drop the power up front, subtract 1 off it, so this is 20x, or 20 with no x on it. And then the next one is negative 40 x to the negative 3.
And that's the one we want.
Oh,
So yes, you can put them in any order you want. I don't care the order actually. So yes, you're absolutely right. And then so the 20, we drop the 1 out front. Again, this is the second derivative of that thing. So you drop the power up front, subtract 1 off the power. If the power is already negative, it will become like a smaller negative number. So, all right, there you go.
That's it for today.
Okay, and the last question of the day. So the fourth one, this is the final question. This is the one I want to intro the next part, what we're doing next. So I'll let you write that down if you need to. So far, this is the Google question of the day. This is what you want to have entered. Okay, so in fact, I'm going to take screenshots of those so I don't forget these problems.
Or do you want to see the coolest thing that I learned?
Yeah, that's what do you got?
What is it?
I'll be back. I'm back with him.
Yeah, I know that you did.
I didn't set mine up because sometimes I just randomly type it up.
What? What's up?
And I didn't want.
I didn't do
I don't know what you're doing.
You can screenshot that and back.
Yeah, I know.
You can like,
I do that with mine.
Is there a setting for that?
yeah.
I learned it on TikTok.
Aha.
You want everything right
Can I do that on an iPad?
Oh, I don't
Does it
know.
have
Maybe
a
it's
glass
the
back?
smart one.
No, it's the back though.
The
Does
back.
it have a glass back?
Back of the
like the
phone.
phone?
Hmm.
I didn't know.
Is it getting talked to?
Yeah. Try it later. Okay. What?
What are they doing?
They're showing me how to take a screenshot on a device by tapping on the back of it.
Isaac, your phone's too cheap.
Oh, I set it so I could call my dad if I tap on the back of my phone.
Ooh, that's fun.
That'd be sketch. That'd be kind of. I'd be worried.
I like it. I like that you can change that idea. So, okay. Hey, last.
That's for kidnapping scenarios, though.
Ooh, I like these. Sorry. Okay, let's go through the last question of the day. All right, so question of the day, here it is. We are learning what they call the quotient rule. Now, this is just an intro day, so don't feel like you need to be an expert walking out of here. So, I just want you to see it for the first time. Tomorrow we'll do a couple of these, and then on Monday we'll do a lot more. Quotient rule is this idea that you can take a derivative when you have a fraction, obviously. So let me just show you an example. So this is going to be my example. So x squared plus 4x plus 3, and on the bottom we have an x plus 1. Okay. So I'm going to show you the idea of how we take the derivative of this thing, right? So it's this little simple formula. You take the derivative of the top, and you subtract. You take the derivative of the top times the bottom, and then you subtract the derivative of the bottom times the top, all over the bottom squared. I'll write it down. So
It sounds like a lot, Miss Ward.
it is. So let me write this down. It is the derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared.
Wait.
Oh, fine.
Just the normal bottom?
The normal bottom squared.
Mr. Hank is cold.
Okay. All right. So now,
Like, does the bottom have a derivative?
No.
Yeah. Not for this one.
it'd just be a
zero.
1.
Just be one.
Just be a 1.
Fuck on.
Okay. So let's walk through this. So here's what we have. So the derivative of the top. So this, again, this is considered the top. It's the numerator. This is the denominator. This is the bottom. So if you want to know kind of what I'm comparing, it's the top versus bottom, right? So let's do the derivative of the top first. So
How is it not just 0 over bottom squared? That doesn't make any sense.
say it again.
Because if you're taking the top times the bottom minus the bottom times the top, it should be the same number.
It's the derivative of the top.
Oh, so it'll change.
Yeah, it
Oh.
changes. And then derivative of the bottom when we get there. So, yeah, so, all right, so let's walk through this. Yeah, good question. So, all right, derivative of the top is 2x plus 4. That is the derivative of the top. And then we take it times the bottom. Well, the bottom is x plus 1,
Oh, shoot.
right?
I didn't have no space for it.
And then we subtract the derivative of the bottom. Well, the derivative of x is just a 1. And then you take it times the top, x squared plus
Wait, do I
4x.
find the derivative on the bottom?
We did, that was the 1. And then all over the bottom squared.
Wait,
So x plus
I didn't write
1
this down.
wait, where'd you get the one?
squared. That was the derivative of the bottom.
Oh, shoot, yeah, I just said that. Plus times the top.
Okay. All right. Anyway, let's kind of walk through.
They're getting mowed around, aren't they?
So, okay, so let's.
Still out there.
Yeah.
Yeah.
Yeah, I just saw them all.
Okay, so let's walk through the actual math here. So if you simplified this out, you foiled it, all that good stuff. Here's what we have. We have on the top, you're going to have, so I'm going to foil, that's 2x squared plus 2x plus 4x plus 4. So that's foiling.
That's the foil, the first one?
The top, that top left corner. Now I'm going to distribute the negative sign to that top right corner. And then this is all over the bottom squared. I'm going to leave the bottom.
Wait, are these all shortcuts of the other thing that we've been doing?
Yeah.
How
So
is that a-
this was technically the answer. Now what I'm just doing right now is I'm simplifying.
Oh, so we can leave it
Yeah.
without simplifying?
I'm gonna simplify it just to show you the answers, because a lot of the times when we do these in class, like on a test, I'll just have you just write down that step, like just you took the derivative of the top times bottom minus the derivative of the bottom times top all over the bottom squared, and you just leave it there. I'm just going to show you what this thing turns into and explain what happened.
It's 1.
Yeah.
Well, things
Yeah, so things cancel here. So what we have is on the top we have, this turns out to be 1x squared. The 2x plus 4x minus 4x is 2x. And then the plus 4 minus 3 ends up being a plus 1. And if I were to FOIL the bottom out, like distribute the bottom, because I didn't actually write that down, this denominator down here, since there's 2 of them, it actually is x plus 1 times x plus 1, which is x squared plus 2x plus 1 if you FOIL that out. And everything divides to make 1. Okay? So derivative ended up being 1 overall. Now, I know I put the thing in the box earlier, that's what I want you to write down. But if you went further, you'd figure out that the answer is just 1.
What is that?
Here's why.
Random small.
Okay, here's why. If you were to actually factor this thing apart to begin with, this is what you would have had.
Oh.
If you would have factored that thing apart. And in Algebra 2, these would have canceled out, and you'd have been left with x plus 3. And when you take the derivative of x plus 3, you get
1.
1.
Wait,
Why did you just tell us that?
I want you to see the actual rule. Now, the reason I bring this up, and you're like, Ward, why didn't we just factor it? You're not going to be able to factor the stuff I'm about to provide you. So, it won't work at some point. So, I want you to know the rule for derivatives, so that way you understand that it is working. So, it does give you the right answer.
I lost you after the.
Tell them to shut up.
You had something about the thing in green, and then the purple I understood, but then after the purple, initial purple. I don't know.
Hold on. Which one? Did you not understand this part right here that I'm tapping? Or was it this part up here?
I understood the one that you just did most recently, but not the bottom one. Like, I don't know how you got to that from that.
From here?
I don't know how to like show you what I'm
Underneath the green.
So the 2x squared plus 2x plus 4.
Yeah.
I get that.
Okay.
I understand that. But then how did you go from there to the one underneath it?
I combine the like terms on the top, like adding and subtracting like terms.
All I say.
And then the bottom, this denominator here, I foiled out, and that's what turned into this.
So how did 2x squared go into... Oh, because you had negative x squared.
Exactly.
You're just going fast.
Yeah. Sorry, I was going a little fast.
Clap it out for him.
All right, I'm gonna leave this on my marker board. All right, that's the last question today. So for those at home, thank you for tuning in. I'll see you guys in class tomorrow. For those that are here, you'll be online tomorrow. Make sure you're tuning into the Zoom tomorrow. I need to pull up the link that I had for COVID Kim. So I need to see the numbers she showed me.
Okay, Ward,
So,
but you're always right.
Now,
when
what
you say
what number where did you get that from? Because I need to see that, and I want to compare it to Kimmy's little thing. So, what?
So, what was the arrow from the x plus 3 to the 1?
This is the function, like this, what I'm doing right here, it's just simplifying. This is just the original function that I gave you, and all I did was simplify it down, right? And this was, this
X plus 3 equals...
is the original item that I gave you. It's the same thing, it's just written differently. And so what I was showing you is like, if we took the derivative of it, the derivative of just this, because this is the original function just written differently, the derivative of x plus 3 is just 1. I'm just showing you a different way to approach that problem instead of doing this whole like quotient rule idea that I'm showing you.
What is this? The worksheet that you gave us? Where is it?
It's on Google Classroom.
Oh, there's like a picture of the worksheet?
Yeah, it's a picture, and I also have a document in case you need to open it.
It's x to the first power, so then you'd multiply by 1 and then the x would go away.
Yeah, exactly. Yep. Oh, yeah.
Okay, let's see Kim.
Okay, I gotta find Kim's little email or little picture she showed in class. Let me see. I gotta pull up my history. Where was it?
Kim who?
Kim Reynolds.
She showed you in class?
No, she had a
She shut down.
she had a
Meeting.
the first real public like announcement. It was more of a press conference today where she talked about COVID cases in the Midwest is an all-time high in the country.
We're the highest.
And yeah, and Iowa's the highest, and basically it's North Iowa has the biggest number. Basically, top of the list was like Wayne County, and then it was Hancock County right after it.
Oh dang,
And she had this picture, and I'm trying to find it. I was looking at this today because I missed the whole conference. So, all right, let me stop this camera here.
I wish the best to all the